Hi everyone, this is Dr. K.G. Shanti, Professor, EC Department, R.M.K. College of Engineering and Technology. In this video presentation, we are going to see about LTI, Linear Time Invariant Discrete Time System, and we are going to see block diagram representation of LTI discrete time systems. First of all, let us see what is meant by a discrete time system. A discrete time system is one which accepts a discrete time signal, say x of n, right? And this system is one which performs operations on x of n. See, it can do any operations on x of n to produce a desired signal, output signal, or we call it as response y of n, right? Now, when I call a system as a discrete time system, when will you call a discrete time system as a linear time invariant system is when it obeys the principle of superposition and time invariance. That is, if there is a delay in the input, equivalently there should be an equal delay in the output. Such a system which obeys principles of superposition and time invariance is called as a discrete time LTI system. Right. A discrete time LTI system is represented like this. See here, x of n is the input, h of n is the impulse response of the system. Then in that case, your output y of n is nothing but x of n convolved with your impulse response. Right. This is going to be in time domain. When I represent in frequency domain, how will I get it? Y of z is equal to x of z into h of z. And you all know convolution in time domain is multiplication in frequency domain. By the way, what is impulse response? How do I get impulse response? H of n is nothing but it is the output from a system when an impulse signal is given as the input, right? Now, a discrete time LTI system is represented by means of a difference equation. So look into the difference equation. Summation of k is equal to 0 to n minus 1. Ak into y of n minus k is nothing but equal to summation of k is equal to 0 to m minus 1 bk into x of n minus k. Right, now what I do is I am just expanding this summation, right? So when I expand this summation, I get this way around a naught into y of n plus a1 into y of n minus 1 plus a2 into y of n minus 2 and so on. And the same way on the right hand side, it is b naught into x of n plus b1 into x of n minus 1 into so on, right? And we always take a naught to be 1 for simplicity of analysis, okay? Now what I do is I apply Z transform. When I apply Z transform, you all know for y of n it is y of z. For y of n minus 1 it is z inverse of y of z. For y of z n minus 2 it is z power minus 2 into y of z. For y of n minus 3 it is z power minus 3 into y of 3. Right? So I apply Z transform on both left hand side and right hand side. Then what I do is I club the common parameters of y of z. In the same way, I club the parameters of x of z on the right hand side. Now, transfer function h of z is defined by y of z by x of z. This we all know how we define the transfer function, right? Now, when I do find out the ratio of y of z by x of z, I get b naught plus b1 z power minus 1 plus b2 z power minus 2, so on till bk into z power minus k on the right hand side. And on the left hand side, what I get, that is on the denominator, what I get, it is a naught. A naught you all know, we have taken it as 1. So 1 plus a1 z inverse plus a2 z power minus 2, so on till ak into z power minus k. So this is how you get the transfer function in the case of LTI DT system, and this is the basic for block diagram representation. There are three elements of realization in block diagram representation. First one is a delay element. So when I give x of n as input, when I give it to a delay element, the output what I get is x of n minus 1. The next element of realization is going to be an adder. See here, if x of 1 is the input, x of 2 is the another input. So output from an adder is going to be x of 1 n plus x2 of n. The next element is going to be a multiplier. See here, x of n when multiplied by a, it is a into x of n. So these are the three elements of realization. Now let us look into an equation which I am going to represent it by using a block diagram representation. What is the given equation? Y of n is equal to a1 into y of n minus 1 plus a2 into y of n minus 2 plus b naught into x of n. Now how do I represent this equation? By using block diagram, right? Now see here it is a1, here you have a delay element multiplied by a constant a1 and then you have a summer, right? So how will I proceed on? See here. I give an input x of n and to the x of n what is multiplied? B naught, right? Next, now look at this one. The output here, generally for any system, input is x of n and the output is y of n. Now look at the first term here, it is a1 into y of n minus 1. Right now when I give a delay element, how do I represent a delay element? Z power minus 1. So if y of n is the input to a delay element, what do I get? I get y of n minus 1, right? Now that is, it is a1 into y of n minus 1. So when I multiply a1 into y of n minus 1, I get the first term, right? And how do I realize the second term? It is y of n minus 2, which means that it has to y of n has to pass through two delay elements. So what I have, the output here is y of n minus 1. Give it to one another delay element. What will I get? Y of n minus 2, right? And this has to be multiplied with the constant a2, right? So when I multiply this with the constant a2, I get a2 into y of n minus 2, and here it is a1 into y of n minus 1, and now I am giving to the adders. In that case, I'll get the output y of n. So this is one example for block diagram representation. Now let us go on to the various methods of block diagram representation. In the current presentation, we will see direct form 1 and direct form 2. Right. Now coming on to direct form 1. Right. Now this is the transfer function of a discrete time LTI system. Right. Now what I am going to do is, when I take a discrete time LTI system, your transfer function is going to be h of z is equal to y of z by x of z. Now what I do is, I insert a dummy variable so that I can rewrite this equation as y of z by w of z is equal to w of z by x of z. Right. Now what I do is, I take w of z by x of z and I equate it to the numerator. Right. And when I rewrite it, w of z, I take x of z to the other side, right? And I'm going to multiply term by term like this. So I'll get w of z is equal to b naught x of z plus b1 z power minus 1 into x of z plus b2 z power minus 2 into x of z, so on till bm z power minus m into x of z. Okay, right. Now this is equation 1, and what I do is, the other term is here, y of z by w of z, that I equated to 1 by denominator in this term. So what I have, this is the term I'll have. Now do a cross multiply. So when I do a cross multiply, w of z is equal to y of z into all this, right? Now I expand it, right? And I expand it and I bring y of z to one side and I take all other terms to the other side. When I take all other terms to the side, here I'll have w of z, and the second term when it goes to the other side, it becomes minus. So minus a1 into z power minus 1 of y of z minus a2 into z power minus 2 of y of z, and so on. So this is going to be your second equation. So see here, w of z is the output on one side in terms of x of z, and the other equation is going to be y of z in terms of w of z, right? W of z and y of z. Right. Now how am I going to proceed on with the implementation? Right. Now those two equations in the previous slide, I am rewriting it. See here. So w of z, equation for w of z and equation for y of z. Right. Now how do I get this diagram? See here, w of z is, first let us see w of z. W of z is nothing but b naught into x of z. So b naught here x of z. So I get the first term b naught into x of z. What is the second term? b1 into z power minus 1 into x of z. Here you have x of z, give it to a delay element. What will I get? The output of this delay element is z inverse of x of z multiplied by b of 1. So I have b of 1 here. So what will be the input that is coming to the adder? It is b1 into z power minus 1 into x of z. Now what will be the, so when it passes through the next adder, it will be b2 into z power minus 2 into x of z, right? So, and when it comes to the last adder, it is going last delay element, the output that is given to the last adder is going to be bm into z power minus m into x of z, which means that there are going to be m delay elements, right? So that is how you implement the equation for w of z, right? That has come on the input side. Now let us look into this equation. What is this equation? Y of z is equal to w of z minus a1 into z power minus 1 into y of z. Now this is y of z, right? Now w of z comes directly. So the constant here is 1. Now what I have, minus a1 into z power minus 1 into y of z. Take y of z, give it to a delay element. What will I get? Minus a1, right? I get minus a1. Now what will be the output here? Minus a1 into z power minus 1 into y of z. So that is the first term here. And so on. So for the second term, what will I have? If I have a line here, it is minus a2 into z power minus 2 into y of z, two delay elements. How will I get the last term? I have to have n delay elements. So finally I'll have it as minus a power n into z power minus n into y of z. So all together I get added. So this is going to be direct form 1. Now let us look into direct form 2. Right now you have the transfer function h of z is equal to y of z by x of z. This is your general equation. The same way what I do is I insert a dummy variable, right? So y of z by w of z is equal to w of z by x of z. In the case of direct form 1, what did we equate? W of z by x of z was equated to numerator, right? But here it's going to be the reverse. So what happens here? Y of z by w of z is equated to the numerator, expand it, right? Get an equation for y of z. Now the other term, what is the other term? W of z by x of z is equated to 1 by the denominator, expand it, get an expression for w of z, right? This is going to be equation 2, right? See here, what is the one change? Y of z by w of z is equated to the numerator, and w of z by x of z is going to be equated to 1 by denominator, and you get two expressions, one for y of z and one for w of z. Similarly, what we got in direct form 1. Okay, right, now let us see about the implementation of this. Now let us look into the implementation of direct form 2. In the case of direct form 2, you have only one set of delay elements, correct? Now let us look into the implementation of first equation y of z. What is y of z? Y of z is going to be b naught into w of z. So b naught into w of z. Second term b1 into z power minus 1 into w of z. So give it w of z given to a delay element. We get b1 into z power minus 1 into w of z multiplied by b1. So we get the second term. How about the third term? You should have two delay elements. In that case, I'll get z power minus 2 into w of z. And what is the constant that has to be multiplied here? b2. Now coming on, so in the same way we will proceed. And how will I get the last term? It is bm z power minus m into w of z. Which means that how many delay elements I should have? Z delay elements I'll have. So what will be the value here? It is z power minus m into w of z. I multiply by the constant bm. I give it to the adders. So a group of adders here. So I get the output y of z, which is going to be this equation. Now let us come on to this set of this equation w of z. What is w of z? X of z. So I get x of z. The constant here is 1. Right? And what is the second term? It is minus a1 z power minus 1 into w of z. So w of z given to an inverter, it is going to be z power minus 1 into w of z multiplied by the constant minus a1. So I'll get the second term, right? And how about I'll get the third term? W of z given to two delay elements. What will be the value here? It will be z power minus 2 into w of z, and I'll multiply. What will be the multiplier here? Minus a2. I'll get the third term. Right, now how about I'll get the last term? Right, a power n into z power minus n. So come here, I'll have n number of adders, right? What will be the constant? I'll minus an. So the term here will be w, that is, it is going to be a power n into z power minus n into w of z, right, and give it to the adders. I'll get the term for w of z. Right, now let us look into an example for this. The example, right, this is the question given. So y of n plus 2 into y of n minus 1 plus 3 into y of n minus 2 is equal to 4 into x of n plus 5x of n minus 1 plus 6x of n minus 2, right? We are going to implement this in direct form 1 and direct form 2, right? So what is the first step? I apply Z transform, get the equation for y of z by x of z. I get this. I insert a dummy variable w of z. For direct form 1, what should be? W of z by x of z should be equated to the numerator, right? I get the expression. Next, what should be the equation? Y of z by w of z should be equated to 1 by denominator, and get the equation for y of z, right? Having got this, I have to proceed on with the implementation. So the equations are written. What will be my diagram? What is the order of the filter? It is 2, right? So see here, first let us see the first equation. It is 4 into x of z. So this is x of z. What is the constant to be multiplied? 4. So 4 into x of z. And what is the second term? 5 into x of z into z inverse. See here, x of z, when it comes through z power minus 1, it is z power minus 1 into x of z multiplied by 5. So that comes to the 0 second adder, right? And last term is 6 into x of z into z power minus 2. So you have two delay elements. So what will be the value here? It will be z power minus 2 into x of z into 6. So you will get this first term. Now what about the second term? How will you get the second term? You will have w of z. So w of z going directly, minus 2 z inverse into y of z. So z inverse is there. Y of z into z inverse will be the output here, multiplied by minus 2. That will be the output coming here. And what about the second term? The constant is minus 3, two delay elements in series. So what will be the value here? It will be z power minus 2 into y of z, and all together you add, you get the second term. So this is going to be direct form 1 example. Now how will I do direct form 2 for the same example? I have this equation. Now what should be the change? Y of z by w of z should be equated to the numerator, right? Get the expression for y of z. Now w of z by x of z should be equated to 1 by denominator. Get the equation for w of z. Correct? Now see here, these equations are from the previous slide. How will I go about implementation? Direct form 2 will have only one set of delay elements. So y of z is 4 into w of z, 5 z inverse into w of z. So here z inverse into w of z into 5, and 6 z power minus 2 into w of z. So 6 into 2 delay elements, z power minus 2 into w of z. So this is the output side. And coming on to the input side, it is x of z minus 2 into z inverse. So you will have 2z inverse into w of z. So w of z into z power minus 1 into minus 2, right? And the last term is going to be 3 minus 3 into 2 delay elements. So z power minus 2 into w of z. So you will get the bottom term. Thank you all students.